Thanks, Neotys team, for giving me this opportunity to present in this conference. My name is Harinder Seera, and I'll be presenting on the topic called Performance Test Tools Not Equal to Performance Testing. All right, so the agenda for today is, first one is what's cooking. It's a funny name, but bear with me. Then I'll talk about current state and what there is to performance testing, and finally the takeaways. So what's cooking? Let's get started. I started performance testing over 10 years ago. The first time when I saw response times graph, they looked like a spaghetti to me. I had no clue what exactly I was looking at. And I basically had to tell my mentor at that point in time, what is this spaghetti? What am I meant to be looking for? How do I analyze? They just look like a funny, weird colors. This is my first day in the basically training to become a performance tester. I was not at the client side or anywhere else, just in-house training. Now, all those concepts that I learned over the years are still valid even now when we are living in the agile DevOps world. So this story will make sense as to what I'll be presenting. So let me get to now, what's the current state of performance testing? Agile and DevOps will has really helped performance testing. Normally, performance testing used to happen at the end of a development lifecycle or your SDLC, where you probably get a week or two to do performance testing and report your findings. And sometimes applications wouldn't go live because they had really major performance issues, and it needed they had to re-architect the whole system. With Agile and DevOps culture, bringing performance testing earlier helps alleviate some of those issues. We can run performance testing early, identify issues and fix them before they become a major issue in production. You get a quicker feedback, which was harder at times. You'll get a feedback, but it's like you're going live tomorrow. That doesn't help. Whereas now you're developing your code, you can run a test, and in parallel you can get your results and you can see whether it's good or bad and whether you can promote it or not. You've got everybody else involved in performance testing, not just your performance engineers, but you've got your devs, you've got DBAs, you've got architects. They are involved. They're working together, which really is quite useful, quite handy. So it's good to have Agile and DevOps culture. But at the same time, I'm starting to see a different perception out there. I don't know what is the reason of it, why it's like that, what's the cause of it. But what I do see is there is a perception where if someone knows about an automation tool, for example, Postman, they think they can do performance testing because knowing Postman, they can learn JMeter, they can learn Gatling, and they can start doing performance testing. Same thing, I see someone might have written an API script in a performance test tool, for example, JMeter. So they think they can now do performance testing. Don't take me wrong. It's good that there are more people trying to learn, trying to get into performance testing world, but the perception is still around performance test tool is what performance testing is. Another perception that I see is if it's not about performance test tool, then it's about performance test framework. I get to hear people saying, hey, we want functional testers to also run performance tests, report on the results, which is a fair point, fair thing. We want to teach them how to do that. But just having a tool like Karate with JMeter, that's not performance testing. So there's that perception as well. Also, there's another perception where this is more from a business point of view, where vendors tells the business, hey, our tool can help you design the test faster, will help reduce script maintenance, and you can integrate with DevOps toolchain. So business thinks if the tool can do that, that means it's good. We can reduce performance testing timeframe. So again, it's that discussion around performance test tool framework without knowing what exactly goes on into performance testing. And in this presentation, that's where my focus will be as to what other things are involved when you're doing performance testing other than your performance test tool. So that's where this next slides will be. They will be talking about that. The first one is called Three-Eyed Monster. This is a concept. It's an old concept, but I just gave it a new name. It's about knowing different perspectives. So when you're doing performance testing, there are mainly three perspectives that you need to be looking for, or you need to have, you need to be looking through their eyes. The first one is your users. Second one is your IT ops. And finally, you've got business. And each one have got different expectations, performance expectations. For example, a user cares how quickly the application responds to their input. Or they might care, hey, do you have the product that I'm searching for? That's what their expectation is. They don't care how many servers you've got in the backend, how many databases you've got, how many TPS you can handle. They don't care about that. Same thing with IT ops. They potentially will care end user experience, but they also have other focuses too. They are looking at, hey, do we have enough capacity to handle sales low during our sales peak periods? Right? What infrastructure do we need to have in place to handle that? Do we have the right monitoring in place to give us that visibility, what's going on? If there is any issue, how can we analyze and fix that? Do we have the right metrics for that? Same thing, if they're trying to increase the capacity, they might need funding. So they might have to write a document, or they need to reach out to business saying, hey, this is how much we need for next upcoming sale to handle the load, how many dollars we need. Right? So even though you might have auto scaling and stuff, but you still need to have some buffer saying, hey, we might be looking at another 10K over whatever we've planned for this financial year. Right? They've got a different perspective, and you need to basically think from that point of view when you're running your test and reporting to them. And finally, you've got your business. They have different expectations, and you need to be able to translate your findings so it makes sense to business. And same thing, you need to translate business requirements into performance goals. For example, saying, hey, our system can handle 100 requests per second might not mean a thing to business. But if you say, business, our infrastructure can handle 1,000 orders per hour, that's far more meaningful for them. So you need to be able to interpret your performance goals into what it makes sense to them, and the vice versa. Because they might not be able to translate into number of requests, or they might not be able to translate into uh, your throughput on network bandwidth or whatever. You need to be able, you should be able to do that on their behalf. So that's your 3I monster. That's the thing you need as part of performance testing, you need to know. Next one is your performance requirements. This is a real world requirement that I've got here. I have anonymized the data. So it doesn't basically tell who the client is and stuff, but the first requirement that I've got is where product owner told me, just test to the requirement, just test the API wise requirement as what it was for API X requirement. And how do you plan for this kind of requirement? Now, I know API Y is a update call that happens to a database, whereas the other API, it's just a query call. One is a heavy call on the database, other one's not. It depends as well, like what kind of data you're querying. But again, there are two different kinds of APIs. So do you still want to have the same requirement for it? Another one, you might be doing 10 or 20 times more. So you might be doing more queries. Would you really be doing that many updates? So we had that discussion, and then product owner had a discussion with the BAs and stuff. They came back with an update requirement. This requirement is far better than the previous one. It's not complete, but it gives me enough information for me to get started or start asking more questions, more clarification questions. For example, in the second requirement, they mention exclude time to make the third-party calls. Now, that's good. So what do I do here? Do I set up a stub to mimic that latency? If that's the case, do we have stub? Do we need to create one? If I don't have it, then what do we do? Second is, do I put a zero latency, because that makes my life easier? By putting zero latency in stub, then I can just measure it from the load test tool, and it will pretty much give me how long our components taking. But that doesn't reflect what happens in real world, where any delay from downstream or third parties can have an impact on the application. Now, if I add the latency in stub to mimic what third party will respond with, then how do I remove that timing? Do I have that capability? If I don't, that's where I need to engage probably other team members, or I might have to write a custom code to handle that, to exclude that time. So you can see what's going on over here. There's far more information, far more things that are required to do performance testing than just your tool. Next bit is, yes, you've got your requirements. Now you need to set up an application simulation model. You need to learn concepts such as spacing, think time. For example, your real world users will wait between pages before making taking next step. For example, they might be reading your product page before they click on the next button, or they might be typing in their personal details for checkout. You need to mimic that. That will influence your application simulation model. That will influence the concurrency on the system. So you need to understand, and you need to be designing that as part of your performance testing piece of work. The next bit is data. Data is becoming more critical in performance testing now, more than ever. I cannot highly stress how critical data is in performance testing. Few times I have tripped over by having incorrect data during performance testing. It can have a huge impact on your test results. Another thing is, if you're going in the path of having your performance testing as part of CI/CD, you need to think about concept like consumable data. Because each time you run your test, data will be consumed. How do you get new data? If it's a reusable data, yes, maybe, fine. Also, you need to mimic skewness in the data. For example, when you're dealing with an insurance company, most of the time it will be the elders who will be applying for insurance. So your skewed data probably would be more like people above 40. Now, if you just put a random data in your test tool, that won't mimic the skewness and could give you results which are not correct and which are not reflective of what's happening in production. Again, if you need to create data, how much data do you need? So there's an effort required for it. So if you're running an endurance test, you'll need to probably set up data beforehand you run that. So you need to think of that. Or another one is, do you add failures in your test? I have seen situations where adding failures had an impact in response times. And not having that, you could not implementing that, you would see production systems are slowing down. And on further analysis, we noticed why it was failing was because the requests that are been sent had wrong data in there. And that's why system was responding slowly. What about if it's a greenfield application? You probably won't have data in the database. So just running a test against empty database is meaningless test. What are you trying to achieve by running a test against an empty database? So you need to think of that during a performance testing. Next bit that you need to know, that part of performance testing is you need to understand your environment and applications. You need to understand what's the differences between your production and your test environment. Nowadays with cloud, you can have same environment test and prod environment. But I've also encountered situations where you've got restriction at account level. So you can have like IP address, number of IP addresses restriction at account level, even though you might have, and you're sharing your account with different environments, non-prod environments. You might have a SIT environment in the same account as your non-pro, your perf environment. They might be in a different VPC, but when you start running tests, you might find you're running out of resources which are shared across that account. For example, Lambda. So as you add more load, you'll start spinning up more Lambdas. Now, there will come a time when those Lambdas will hit a limit because they depend on the IP addresses, amount of IP addresses. So you might end up consuming all the IP addresses, or someone else might end up consuming IP addresses while you're running your test, and suddenly you see this slowness in your response time. So you need to be wary of that. Another one is what kind of metrics you need to capture. Right. So you're running your test. What do you look at? Whether my test ran successfully or not. Like, do you look at CPU metrics? Yes, You can look at CPU, but like Linux operating system, you can split the CPU utilization into different components, different parts. So you've got your user time, you've got your system time as well in there, and you've got your IO time as well, whether it's waiting for from responding from disk, wait IO. Then also understanding your architecture, how things fit together, how they communicate with each other. You need to know that, because if you have that understanding, when you encounter a performance issue, bottleneck, you will be able to identify where the problem lies. Otherwise, you might be chasing a rabbit hole involving a lot of people, and each one might not even understand the full stack. Like DBA wouldn't understand what's happening at the network level. They might not even understand what's happening at the application level. Same thing with your developer. They might not understand what's happening at the database level. So you need to be able to understand how all these components fits together and how they interact, what different configurations they've got. So that's another thing as part of performance testing you need to know. Next comes execution. Good that you've come this far. You have designed your model. You know the differences in the environment. You got your test tool as well. But what kind of tests are you going to run? All right. For example, if you got releases every 2 weeks or even every day, do you plan on running an endurance test every day? If not, what kind of tests are you going to run? When can you plan running endurance test? And what is the appropriate duration for the test runs? For example, if you're looking at the e-commerce websites, they will potentially be caching the data across a lot of different layers. And over time, cache will expire and it will be evicted. Data will be evicted from the cache. Do you test that scenario and the impact it has on your application? I have seen situations where someone just hits the application with a full load. So all the data gets cached in the application for 4 hours. And while the test is running and it crosses 4 hours, suddenly the whole cache, because the way the caching policy was working, it evicts all the data in the cache. Now, at that point in time, all the requests are now hitting the database and it brings down the database. That test might be appropriate and might not be, depending on what our performance goal or objectives were. Because if it's an e-commerce website, you wouldn't see all the customers hitting at the same time. They will probably come online gradually. So you might have to mimic that scenario. Another thing is, who do you notify when you're running your test? There might be teams that need to be aware of your test runs. So that's another thing you need to consider when you're doing performance testing. Next bit is analysis and reporting. You need to understand key mathematical principles like averages, percentiles. When do you use averages and when you don't? Then you need to know how to slice and dice data to identify different patterns, right? Same thing, how do you make sense of the data? Once you've got the data, how do you compare and report, right? You might be able to compare in an Excel file and use that as your documentation reporting mechanism for approval. Or it might be a proper Word document, or you might use a Confluence as your reporting mechanism. So you need to know how you will be basically reporting and saving your data as well. Finally, how do you translate your data into a meaningful information? Now, next slide, I'll give an example, a real world example of how slicing and dicing a data help identify where the problem lied. Now, I won't go into much details because Stein will be presenting on a topic called raw data. So I believe he'll be going into more detail on slicing and dicing the data. So therefore, I won't go much into detail on in this presentation. So it's worthwhile watching his presentation. So let's get started on this example. So if you look at the metrics overview, at the top, I've got two APIs that I'm testing. After the test run, I get the results in a tabular form with different statistics. And from the statistics, I can see my 95th percentile has passed SLA. The SLA was 1 second, so it's less than 1 second. And also the error rate is less than 0.5%. So again, it has passed SLA. But what it's missing is the pattern, which is what's shown in the graph below. You can see like 1 hour, 10 minutes into the test, my throughput as reported by the load testing tool drops from 100 requests to roughly 40 requests per second. At the same time, the response time degrades from 300 milliseconds to 3 seconds, 3.5 seconds. That pattern's not shown in those statistics. So if you were just reporting that, you have missed out a potential problem in the application. And now to identify where the problem lies, I slice the data even further. So I've gone into 1 second graph of the throughput or request per second. So you can see around 11:25, there's a gradual drop in the throughput. It's not immediate, but it's a gradual. All right. Now, if I zoom into that part of the test run, you can see it clearly dropping off, gradually dropping off. But before that, there's a drop in the throughput to 0 TPS. Right? Now, why that is a discussion of for some other day. But is this a load testing tool issue, bug, that it's just only showing 0 or not? To understand that, I now started looking at the application logs. Now, when I look at the application log, I can see the same pattern. I can see there's a gradual drop, which is good. So that's a good thing. And also, before the gradual drop, there's a drop in the throughput. That tells me it's not my tool. So I can rule out that it's not a bug in the tool. It is the application that's behaving like that. Another thing you can notice is my load testing tool was showing 100 requests per second, whereas application is showing 80 requests per second. So if you know the application, you can basically rule out there's no issue over there because that's how the application is meant to behave. Right? Now this graph below, I basically even split up that throughput to look at per server level, what's the throughput, which now gives me a different pattern. What it's showing me is one of the server throughput drops to 0, whereas the other server throughput gradually is dropping. Now, because I knew the architecture, I could basically pinpoint where the problem was happening, what was causing this issue. It was our load balancer. Load balancer was configured to round robin policy. So when the first server basically stops responding, other servers are still responding, but as all those requests, it's round robin, so they come to the last server, they gradually basically drop off on the all other servers, right? And then when that server which is not the healthy server starts responding, everything goes back to normal. So now I know I've got an issue with the policy. Second bit is load balancer needs to have a capability to take out the server that's not responding correctly. And finally, we need to find out why that server is not responding. So with just by looking at different graphs, we're able to come to a conclusion and we're able to hone where we need to be looking at and fixing the issues. That's one of the things you need to be wary of in performance testing. You need to be doing that. So it's not just about tool. Also, you need to shift right too. Once you've done your testing, you need to know what you have done is valid and it's what you're seeing in production. If in production, it's totally different things are happening. Your application simulation model does not reflect what's happening in production. You need to replicate that back into your test environment. Provide that feedback so you can fix it, so you can run as close to what's happening in production. Emulate the same kind of behavior. Also, finally, performance testing, you need to know all other skills too, like front-end performance. You need to be aware of soft skills, different kinds of architects, protocols you need to know. So it's not about just the tool. There's a lot of other things that goes into performance testing. Finally, the takeaways from this presentation is there's a lot more to performance testing than performance test tool. So performance test tool is not equal, not same as performance testing. Have mentors around you to help you guide in the field of performance testing. Even though you're embracing Agile and DevOps culture, performance testing concepts are still relevant. And finally, performance testing is an ever-learning field. Thank you. If you got any questions and you need to contact me, the details are below.
All right. I think we came to the end of the video, at least from my end. I hope that everyone has the same experience. I'm so glad that you did the presentation because you cover the activities and you made the point. I think what we usually discuss is that people intend to have remote performance tester is a lot of things behind the term performance engineering, so communication, and I think communication is highly important. It doesn't make sense to start digging in problems, and if you don't know how to explain them to non-technical folks, otherwise it's going to be very hard for the other team members to understand the results that you came out. So thanks, Harinder, for that. At least it's highly important.
Don't worry.
And I think also what I like is the last piece where you said shifting right. I think even shifting right should be the start. Don't do the wrong simulation, and you're spending time for nothing. I think it's very important to get the right workload model that reflects real life. I heard so many times customers or any team members saying that performance testing doesn't make sense because it never reflects real life. I think that type of quote prove that people is always thinking that performance testing tools does everything, and I'm fully aligned with you. I have no major questions for you, except to comment what you just said. I think pretty good presentation, and really happy that you presented that. I'm looking at the Q&A from the audience. There's no major questions for your presentation. I have enabled the webcams of the other PAC members. So if there are any questions from the others, please pop them. Harry is connected. I can see him, but he didn't have. You have not enabled your webcam yet, Harry. I don't know if you're hearing me, Harry, but if you have any questions, please. Okay, Ramya, I think I'm going to mute yourself. I think there is some background noise. All right, so I think there is someone. All right, so there is a question from VJ. During performance testing, my web app works perfectly for 1,000 users. When I put load of 1,500 users, I receive read timeout errors. Server, CPU, and memory utilization was okay. So, do you have any idea? So here I think we should have the results, Vijay, to be able to dig down the problem. Harinder, do you have any suggestions to that problem?
Yeah, architecture, it's a bit hard to say read timeouts are happening.
Hey, Harry.
Hey.
Hello.
How are you?
Good. Henrik, how are you?
I'm very good, thanks. Harry, do you have any questions for Harinder?
One quick question. I think you spoke about shift right, and you also spoke about some of the metrics that you capture, right? So what kind of apart from, do you use these standard APM tools, or are there any other native tools that you use to capture some of the metrics that you outlined?
So I use lots of different tools. I do use APM. Also look at the native. So I run VM stats, I run IO stat, MP stat. I just pipe it to a file and then try to analyze. Because if I look at, let's say, most of our application, I don't get granular information on the disk, how my disk is doing. So I run Nigel's monitor, nmon, on those servers, and then use Excel file. So it's whatever can help me analyze and debug the issues, I'll use it.
So what is your process, by the way? You're collecting everything, and then you're similar to what Stephen and Shrivali or Scott presented previously. Are you collecting all the data and then use solution like Tableau or R to do the analysis and the data visualizations, or how do you process from your end?
So I normally use Splunk. So Splunk in a company, so I use Splunk. But I do use R, as I was mentioning in the comments. I'm not an expert like Scott, but knowledge of slice and dice data with that. But I also use Excel. Good old Excel. There have been lots of times where I've just used Excel and it just makes my life easier. Other ones I've created my own tools. Like Scott mentioning, I'm probably the young guy in there. I'm using Python. I don't use Perl. I create my own tools as well.
So you're using Splunk to take advantage of the index, all the correlation that they have as well.
Can you repeat that question, Henrik?
Because I didn't hear it. Did you mention Splunk as a tool, or was it something else?
Yeah, I use Splunk. I use R as well. There's another one called Dataplot. That's an open source tool. It's a simple. I'll put the link for that one. I use that. I also use Excel.
Traditional Excel sheets.
So anything that can help me. Yeah.
Okay.
Sorry,
So,
I think the connection is pretty bad.
Yeah. So you have some your voice is breaking here and there. So basically, just to tell you though, later on today or this evening for us, we have Todd from Splunk who will do a presentation, and he will try to show us some example of queries that you can do on indexes. So basically, the only thing that you have to worry when you have a Splunk in the picture is basically pushing your data to the right index, and then building the right query to build dashboard or any visualization for your data. So we'll learn more later on today on that. Harry, do you have any other questions for Harinder?
Hi, Harinder. I have one question for you.
Sure.
Okay, so it was a good session, Harinder. I mean, talking about covering a good amount of insight on what is it other than tool is very important, right? So now, from your perspective, with DevOps environment becoming the strategy everywhere anonymously, what do you think is the difference that has happened in a performance testers toolkit? How different it has become? I mean, maybe a decade back versus now. So what is the key deviation that you could see from your experience in the performance testers toolkit?
Learning about basically Jenkins, one of the things, tools I've noticed movement away from your commercial tools to more your open source tools. And then knowing about, in my case at least, knowing about the cloud side of things, because that's where I'm seeing everybody moving. And that's where all our applications are moving towards. Part of our DevOps culture is to understand how cloud works, how things are set up, lift and shift. What are the challenges you're dealing with lift and shift patients? And learning new tools, learning about Lambda, learning about API gateway. So it's the whole different knowledge that you're starting to look at, or things you're starting to look at. I hope that answers your question.
Absolutely, Harinder. You're absolutely. I mean, I think in nutshell you covered. I mean, I think we were just focused too much on learning a tool earlier, but now I think there is the demarcation between tester and engineer is all, the boundary line itself is decreasing, and we all are becoming tech savvy to understand more into the technology, not just with the tool knowledge, right? So that awareness, I could see a very good improvement as years pass. I think you also had a very similar thoughts. I mean, thank you. Thanks for your input.
Yeah, I agree. I think
There's
people were. Yeah. Okay. So yeah.
There's one thing. Sorry. One thing I didn't mention in my present book. The network side of things. If you are like dinosaur, like myself, understanding TCP, understanding how TCP works can help you quite a bit. So even if you're looking at your end user front end performance testing, how everything fits together, understanding how network works is quite useful, quite handy to know. And you can find lots of issues just looking at the network tag.
Yeah, definitely. Thanks. Right.
Yeah, I think we agree. I think we used to have focus on mainly we need to perform and test, so we focusing on building the right testing assets and configurations. So we were focusing our main effort on tools, configurations, and design, rather than now I think people are expecting more about, okay, so we generated tests, give me some insights, give me the reason, give me the why we're having those issues. We used to have that as well as a requirement previously, but now it's more important. I think it's related to the fact that performance has become more important than a few years back, where people are expecting more from us than it used to be 12 years ago. I don't know. That's what I think.
There's another thing, because I also work in the operation team. I noticed with the DevOps culture or even microservices, one of the things I noticed is the response code, error code, sorry. The way how all these microservices interact and they respond, you can spend a lot of time just going through the stack and figuring out which error code reflects what. So that's why I was asking earlier on about 429. I've seen situations where downstream throws HTTP 500, that gets translated into 429 response code. That's the application, and it sends back to the client. Now I've got in our application stack, we've got, we're using Kong. So Kong, you can set up a rate limit, which will also throw you 429. So if you're in an operations team, you're setting up a dashboard of saying, of errors of 429, it masks what's happening at the application level, because application is also throwing 429, but just only have plotted number of 429. And you might think, it looks like someone's hitting us really hard, so we're just throwing them. But in reality, it's the application that's throwing 429. But that was translated from HTTP 500 to 429. Those things, once engineered.
There's another question from the audience, and I think it's going to be very hard to answer it, but because there's a lot of things involved behind the answer to that question. But what can be done to mitigate test data issues while doing performance testing in CI/CD? If test data are not reusable, so you mentioned that on your presentation, what can be the workaround for that type of context?
So I'll just tell from my experience that the way we have done is in our CI/CD pipeline, before we run our test, we make a call to the database or check the data. So it's part of the CI/CD pipeline. It makes a call, gets the data, and writes to a file, which then gets picked up by Jenkins' job for performance testing. But that's how we mitigate that issue of consumable data. That's the strategy Another one is if it's empty, if it's a greenfield, it will be hard, basically, how you generate the data. If it's a greenfield application, you might have to talk to BAs, business product owners, to see what kind of application it is and try to mimic or create data with that. But yeah, it's a bit hard. It's a greenfield.
Yeah, test data you have a network issue from your end. Your voice is breaking quite a bit, so it's very complicated to understand everything. But basically, what I heard is that you have a job that extracts the data from a database, generate it, and push it to the load testing product. So that's how you can automate and do that in CI/CD. Is it correct? Okay. But yeah, test data is very expensive. So you need to take data to handle it as early as possible, because it's going to be one thing that could block your automation or the results of your test, or the efficiency of the test that you're going to run. So having a test data management product could help you out. There is a lot of tools on the market, a lot of different solutions that can do. They could generate data. They could, of course, they do the data masking and so on. But yes, data is expensive, and we need data to achieve your test properly.